Hello, in this video we will discuss example of analysis of variance. How will once we have a sample data is given, how will calculate the analysis of variance. So there are the several steps we will discuss one by one. Like for example, birth weight in kg of babies born to women classified according to their health status are given in this table. Like women health status is for example good or fair or poor health status of women or mothers, and they have delivered the babies which birth weight is given like 3.1 kgs, 2.9 kgs, 3.5 kgs, 3.6 kgs, 3.4 kgs if mothers are having good health conditions. If they have a moderate fair health conditions, then birth weight outcome is coming like this. And if those mothers health status is poor, then birth weight is recorded like this. So now we have three groups and each group's birth weight is given. Then now we are going to apply ANOVA, and with help of the ANOVA we will try to find out is there all three groups means are equal, birth weight means are equal or not. Let's have a solutions. Stepwise step we'll discuss here. Now, first of all, N sample, total sample will see in first group, those mothers' health is good. There are 5 mothers, and fair, there are 7 mothers, and poor health condition of mothers is 10. Three groups, each group sample size is given. Now, next step will add the total of the birth weight. For group 1 is 16.5, and total birth weight is for second group 18, and those mothers are having poor health condition, in that case is 22.4. Now we'll calculate the mean. As mean we know this is the total sum of the total number divided by total number of observation. We'll get this value divided by 7 will get this. And mean, as we know according to formula, summation of the x means total number of observation divided by number of observation is, then we are getting the means. As we know techniques of the ANOVA, there are three groups, each group's mean is given. Now we have to apply the ANOVA concept, and we'll try to find out is there variation or not. So now we have to create the null hypothesis. What is our null hypothesis or alternative hypothesis? So test whether the difference in mean birth weight of babies among the three groups of women are statistically significant or not, whether birth weight is associated or not with mother's health status. So in other way we can say null hypothesis, there is no difference among the mean birth weight, and alternative hypothesis we can say there is equal mean birth weight among the groups. So this is null hypothesis and alternative hypothesis given. Now we will go stepwise for calculation. So as we know, total number of observations, sample size across the group, so we'll add total number is 22, and we have to write down how many groups. There are three groups as according to example. So the total degree of freedom and variation are partitions into various components. So now we have to find out various degree of freedom with help of the formula. So let's see how we'll get the degree of freedom. So first of all we try to find out total degree of freedom. So total degree of freedom, we can find out total number of observations minus 1. So total number of observation is total number of sample across the groups. All three groups is 22 minus 1. So we can say total degree of freedom is 21. And now we have to find out the group degree of freedom. So group of degree of freedom, we can find out total number of groups minus 1. So as we know, there are three groups. First group is the women health status like good, fair and poor. So 3 minus 1. So group degree of freedom is 2. Now we have to find out the error degree of freedom. So error degree of freedom, we can find out total degree of freedom minus group degree of freedom, as we have calculated this and 21 minus 21. So this is the 19 is the total error degree of freedom. Now we have to find out the compute correction factors. We have to find out the correction factors. How we'll get it? Correction factors, will calculate it. Then we have to find out the total sum of squares. Then we have to find out the group sum of square, and we have to find out the error sum of square with help of the different formula. And now we'll calculate correction factors. How will you get the correction factor? We'll add all the values, all 22, means all three groups, each values, each birth weight we have to add, and then we have to square and divided by total number of the samples. Total group 1 plus group 2 plus group 3. So total n is the number of the samples. So once we'll add, we'll get this value 57.8 whole square divided by total number of observation 22. So correction factors here we are getting 151.86. Now next point, we have to find out total sum of squares. So how we'll get the total of sum square? So we have to square each value in given data set among all three groups. So all three groups, each value we have to square, then add and minus correction factor as just we had calculated. So we'll square, and once we'll add, so we'll get the 1.56.42 minus correction factor we have calculated 151.86. So this value is coming 4.56 is the total sum of square. Now we have to calculate group sum of square. How will get the group sum of square? Total sum of the first group whole square divided by number of observation of the first group plus sum of square of all the observation in second group whole square divided by total number of observation in second group, and again in third group total sum whole square divided by number of observation in third group minus correction factor. So this value once we'll add it, so this will get the 15.6 and correction factors already we have calculated, and we'll get group sum of square value is 3.80. And now we have to find out the error sum of squares. Error sum of square, we can calculate total sum of square minus group sum of squares. Already we have calculated total sum of square 4.56 minus 3.806 is the error sum of square. So all these things we are calculating because all the values required for the getting final solution of the analysis of variance. Now next points, mean sum of squares for group and error we have to calculate. So how we'll calculate here? Mean sum of square, mean sum of square for group. We can calculate sum of square for group divided by degree of freedom for group. Sum of square for group we have calculated, and degree of freedom we have calculated too. So that means sum of square for group we are getting 1.9. Now mean sum of square for error, sum of square for error we have calculated, degree of freedom for error we have calculated. So we are just putting the value here, and we are getting mean sum of square for error is 0.04. Now Fisher's F statistics for testing the statistical significance of the difference in mean values among groups is computed as like mean sum of square for group. We have calculated mean sum of square for group divided mean sum of square for error. So we are just putting the value mean sum of square for group we have calculated here, and mean sum of square for uh, error we have put the value, and we are getting the value mean sum of square for group. Mean sum of square for group we are getting 47.45. Now all the above given details we have to put in the tables. So tables, so we can find out source of variation degree of freedom is 21, and due to mother's health status degree of freedom group is 2, and error degree of freedom we have 19. Then sum of square we have already calculated 4.56, and 3 due to mother's health status group 3.80, and 0.76 we have already calculated, and mean sum of square for group 1.90, and for error we have calculated, and f ratio we have 47.5. So here just in previous table, so this is the f ratio value. Here we have written this one, so this is the by mistake, it would be the f ratio values, we'll calculate it. So already we have put it in the table 47.5, and p value is given less than 0.001. So now we have to find out f 2 is a degree of freedom for group, and 19 is the degree of freedom for error. With help of that, this tabulated value 3.52 is given. If we are following this traditional methods, so this is the tabulated value, and if we are taking applying the software, so alpha is 0.05, and f value alpha is if 0.01, so then this value is coming here 5.93 tabulated value, and calculated value 47.5 and greater than f, so alpha is 0.05. So here interpretation is if tabulated calculated value is greater than tabulated value, then null hypothesis is rejected, and if p value is less than alpha, then null hypothesis is rejected if greater than p value. So if modern methods means using the software, then we'll get the p value, and if you are using this traditional method, we'll get that this tabulated value and the calculated value. So now we have to decide, you are going to take the decision at 10% level of significance, or 5% level of significance, or 1% level of significance. It's a choice of the researchers. Now conclusion is that here difference in mean birth weights among the three groups are statistically highly significant, as we have already rejected the null hypothesis. Then we can say birth weight of babies is significantly associated with mother's health status at level of 99% confidence interval, confidence level. Or in other way, we can say better the health status of mothers, higher was the birth weight of babies. So this is the conclusion of the final solution and conclusion of these three groups of the per ANOVA test for birth weight baby if mothers is healthy status. So this is the basic steps for calculation of the ANOVA if you are going to following, and these steps called the traditional method, and same data if we are putting in the software directly getting the p value, that is known as the modern method. In this way we can solve the ANOVA and analysis of variance related problem. Thank you.